What's up, guys? Welcome back to the channel. Today on this video we'll be doing the following function here. As you can see, this is a polynomial. I hope we can able to solve this one. So before you continue, try to pause and solve this problem, and let's see if you're gonna get the same answer as the one that I'm going to get at the end of this video. Now, if you're new on this channel, just know that I've made lots of videos on derivative. All these functions that you see here, we have trigonometric function, exponent, logarithmic function, and the standard functions. I've made derivatives videos about them, and also I've made videos on trigonometry, expansion, and limits. You can go to the playlist section to watch those videos. And if you want to watch more videos that I'll be doing, do not forget to subscribe, because I'll do lots and lots of videos when it comes to maths. All right, guys, so let's start. Now, from the last video, I mentioned that you must always check your what is the term that you need to pay attention to. Each and every term, it has its own derivative. Now let's start with the first term here. I hope this is visible. Let's start with the first term. As you can see, the first term, it's trigonometric function, and then the second term here is going to be exponent. As you can see, x is an exponent there. The third term is a logarithmic function, and the last term is a standard function. So now, if you can able to see these terms, you can able to identify, you will know which function or which derivative I could use. So, but before we start, let's first simplify any of the terms here that need simplification. As you can see, the first term is fine, doesn't need any simplification. The second term is also fine, but the third term, it is not okay because we have a surd here. So we need to get rid of that surd, and the last term is also fine. So whatever I'll be doing right now is to get rid of that side. So let's simplify before we derive. So obviously the first term, you write it as it is. Let's try to be quick because this might take lots and lots of time. All right, plus half. So look at this, guys. We know that if you want to get rid of the surd, we know that you can change this into exponent. This is 1 over 2, the exponent, minus 5 over 2 and x to the power of 4. All right, so we have to continue. Guys, do not differentiate unless everything is in a right form. So do not differentiate, guys. Do not differentiate. So as you can see, I'll rewrite this as they are. But let's look at this. There's a law. Let me just remind you, there is a law from logs. When you have a log, maybe x to the power of n, there's a law where you can say n multiplied by log x. Remember this law, you take this n in front there. So as you can see here, we have x to the power of half. So meaning we can also use this law to simplify that log there. So if we remember, we already have half here, 1 over 2, we already have that. If we take this 1 over 2 here, we have to multiply it again with this 1 over 2 from our exponent, and then we're gonna be left with log x minus 5 over 2 and then x to the power of 4. All right, guys, this might take a bit long, but it's necessary, guys. Okay, it's gonna make our life easier when we differentiate. Now this is gonna be sine 2x minus 3 to the power of negative x. What is half multiplied by half? This is gonna give us 1 over 4, and then we have log, and then we have x minus 5 over 2 and then x to the power of 4. Right, now when it's like this, it is now simplified. Okay guys, when it's like this, it is now simplified. Now you can start differentiating. Remember guys, all these steps, it was just to fix this one here with the log, with the start. As you can see, this is what we're doing so that it can be like this. Now let's start with our first term. I hope you can see the first term here. We have 7 sine 2x. Now this is a trigonometric function, so I'm gonna write the functions here. Let me just draw a line. I'm gonna write the formulas here because these formulas I'm gonna refer them, and then we are able to see what's happening. So the general formula for this one, since we have k, so we can say k, and then we say sine, and then we also have the coefficient of x, so we do have n x. So dy over dx of this equation here, we know that since we have k, it's gonna be, let's start with n. Since we have n, so it's gonna be n and then k, and then the derivative of sine is cos, and then n x. All right, so this is what we should do. So as you can see, this formula here, we have to substitute it where there when we find here, when we find our dy over dx. But then another thing that you need to know, what is our n when we look at our formula this side? What is our n and k? So n is going to be 2 and k is going to be 7. So we need to write them here so that we don't get confused. So we know that k, it's what? It's going to be 7, and then n is what here? It's going to be 2. So we have to substitute this formula. We have to substitute this formula here, there. Now let's do it, guys. Let's do it. So dy, I hope the space is going to be enough, over dx. So if we substitute, let's look at our n. It's 7. So we have to n is not 7, guys. N is actually 2. Okay, n is 2. So let's write it. So it's gonna be 2 multiplied by k. What is our k? Our k is 7. There we go. Right, and then we have cos. So it's gonna be cos n. What is our n? Our n is 2, and then that is x. Guys, if you don't know where this formula is coming from, there is a video where I explain this formula, how to use them. There are plenty, but I also explain how do they come about. Go and watch that video. All right, now let's go to the second term. So the second term, as you can see, the second term, we have exponent there. It's -3 exponent -x. So let's create the general formula. Let's write the general formula for exponent. So we know that this is going to be y, and then we know that the formula for exponent function is going to be a, and then we have and then we have x. And then when we find the dy over dx of this formula here, remember we don't have k, so this one is like that. So the dy over dx is going to be n, and then a, then n x, then we say multiply by natural log a. So this is our dy over dx of this type of a function. Now when you look at our equation there, and when you look at our problem there, we do have n. Remember, n is a coefficient of x. In this case now, our n is going to be -1. That's the only thing that we have here, guys, is the n. So it's going to be -1. We don't have anything else. So a as well. A is going to be 3. Remember, a is the base here, guys. So let's substitute. Now we're going to substitute this formula here, there. Okay, So please do not guys make those mistakes. So let's look at it. We have minus already, this minus here, but then multiply by n. So this n is gonna be -1, and then now we write our a. Our a is gonna be 3, and then we have n, which is -1, and x. Then multiply by natural log, and then base 3. That's it. So what we did here, we just substituted this formula here, there. I hope you guys can see, because it's a lot that is happening here. That's why I'm taking my time. I'm a bit slow about it. Okay, I'm taking my time. All right, now let's look at the fourth term. I mean the third term. This is the third term, the one that actually made us do all the steps, the one with the log. So this one here, as you can see now, we have a log. Now before we continue guys with the log, if you don't know where this is coming from, again I am going to add a video there on the icon. Go and watch that video there guys. Okay, all right, let me just erase very quickly. Okay, all right, so let's look at the third term. We have log. So when we differentiate log, let me just do it. So we have y, and this is gonna be we have k this time around. We have k, and then we have log, and then we have our base. Let's say our base here is a, and then we have x. And then when we find the dy over dx for log, basically this is straightforward guys. You can write it like this. It's gonna be k, right, over it's gonna be, in this case, yeah, it's gonna be, let me just do this guys. Let me not say k over, let me just say k multiply by, now what is the derivative of log? The derivative of log is 1 over x, and then natural log, then the base there. You can also continue, but I don't advise you guys to continue here, because usually you can leave it like that. You can change the log, the natural log, and make it the standard log. Remember the base is e here, and then the a here is gonna be there guys. This formula here, we done the videos explaining the natural logs and the standard form, the standard logs on this video. Go and watch that video on top there if you don't understand where this is coming from. Okay, now let's apply the very same problem, or the very same formula here on this problem here. Remember, it's for this one here. Now before we start, we need to know what is our k. So our k on this one is gonna be 1 over 4. Remember, this is k, remember. And then our a, if the log, now I have to remind you guys, if the base of a log, it is not written, as you can see here, we don't have the base guys. Okay, if it's not written, the base of the log usually it's 10, so meaning a is gonna be 10, right? And that's it. So a is 10 and k is gonna be 1 over 4. So it's time for us to substitute this formula here. Let's start with this one, this formula here, and then when we derive. All right, let's do it. So we have plus, so let's do it. So we have, what is our k? Our k is 1 over 4. All right, multiply by, and then 1 over, so we have x, we are fine with x, natural log, then our a, what is our a, which is gonna be 10. There we go. And then we have the last derivative here, the last what is this, the last term here, which is the standard derivative. So this one should be easy. Even the formula is not that difficult. Okay, let me just show you the formula. So the formula for the standard derivative usually, it's very simple. We have y, then we, in this case now, we're gonna have k. So, and then we have x to the power of n. Now when we find the dy over dx for this one, it's gonna be n multiplied by k, then x, oh, then x n minus 1. This is a standard formula, guys. I hope you remember this one. If you don't remember, there is a video there. Okay, I'll always put these videos there. Go and watch that video so that it can help you guys understand how to use this formula here. All right, but then what is our k here? Our k is equaling to 1 over, it's 5 over 2, by the way. It's 5 over 2. And then our n, what is our n? Our n is equaling to 4. So let's do the derivative. Let's derive this one. As we derive, what we need to do is to take this part here and apply it there. Now let's see if we're gonna win. So first of all, you have to multiply by n. So our n, what is our n? This is gonna be 4. All right, and then our k, what is our k? K multiplied by k, k is gonna be 5 over 2. And then we have x, and then what is our n? Is gonna be 4, then minus, remember, n minus 1, minus 1. Oh, I hope you can see, guys, because I tried to cram everything in there. As you can see, this one here is the same as this one here. Guys, you can rewatch this video if it's so happen that you don't understand some other parts here. I know it can be too much. It doesn't have to be this long, by the way. It's just because it's long because I am explaining everything here. So let's simplify. Dy over dx. Let's start with our first term. Our first term, we have 2 multiplied by 7, which is going to give us 14. And then we have cos 2x. We are fine. The second term, we have negative 1 multiplied by negative, which is going to give us positive, and then multiplied by 3 to the power of negative x. There we go. And then multiplied by natural log 3. All right. Now, what about the third term? The third term, we have 1 over 4 multiplied by 1 over x natural log 10. So this is going to be plus. I hope we're going to have enough space. Plus, put plus here. It's going to be 1. Can I make it 1? 1 over 4x natural log then 10. And then the last one, the last term, which is going to be, what is 4 divided by 2? This is going to be 2 multiplied by 5, and that is going to give us 10x. And then when you look at our exponent is 4 minus 1, then our exponent is going to be 3. So this is our dy over dx. But remember what I said on the first video. You can go and watch it on the end of this. At the end of this video, there is a playlist that's gonna appear. Go and watch it, guys. I said to you guys, never leave the final answer with a negative exponent. So let's try to avoid the negative exponent. Dy over dx. Let me just open space for us guys here so that we can see. Okay, dy over dx. So let's see, we still have 14. This one is good. Let me close this part here. 14 cos 2x, right? But let's look at our 3 there. We have 3 to the power of negative x, so we have to get rid of that negative. So on the numerator we're going to be left with natural log 3 divided by 3 to the power of x. Remember guys, when it's like this, it means that this negative, when we take the denominator, the base to the denominator, the exponent changes the sign. So this is that one there. All right, plus, let's continue. This one is fine, so we are fine here guys. So we will have 4x, and then we have natural log 10, and then the answer is going to be minus 10x to the power of 3. Guys, this is our final answer. I know it was a bit long, but this is our final answer. I hope you understood guys. Leave it like this. I think when it's like this, it's fine. And then again, if it so happened that you didn't understand, rewatch this video. I assume that you can able to see what's the problem there. And also don't forget to comment, like, and subscribe to the channel. This video really help you guys. Share this video with your friends. And at the end of this video, there is a playlist. Go and watch that playlist in order for you to understand other problems that are similar to this one. Remember guys, on the playlist section of this channel, I have made videos based on these derivatives that you see here, these functions that you see here, the trigonometric function, the exponent, the logarithmic function, and the standard function. I made videos on this function. Go to that playlist section, go and watch the ones that you don't understand very well. Thank you very much guys for watching. Till next time, cheers.